I want to introduce you to Mike Rys. Mike has derived a framework for a unified theory, an all-encompassing, coherent, theoretical framework of physics that he believes offers a plausible and valid explanation for gravity and links together the dynamic and observed physical interactions of the universe. The presentation he has is based on a description of gravity and anti-gravity in a paper he published on his theoretical work. So his entire paper goes a lot further than what he's going to be talking about today. He's going to be focusing on gravity and anti-gravity today in this presentation. So without any further ado, Mr. Mike Rys, sir.
Hi guys, how's it going tonight? Let's see if I can get this guy to work here for you. Let's see if I can grab that screen.
Okay, and Mike, I have done the spotlight, and
okay. So you can see this PowerPoint just fine.
No, actually, it's focused on you right now. It's just you. Yeah, try share screen and then select the PowerPoint, and maybe in your other window.
Got it.
Yeah, and no stress. Everybody has issues with PowerPoint and Zoom.
I can do that. How's that?
Nope, sir. It is still just showing you.
Well, we didn't.
So yeah, you're doing the share screen, right? And then it'll have you select, and then you have to hit OK. It doesn't look like you're sharing your screen completely yet.
Okay, got it. I think I got this thing down cold now. I think we're good now.
Okay, and it's starting up. Okay, so now it is showing your Windows desktop.
Super.
Yeah, and if you want, you could just run, if you just, yeah, there we go. Perfect. Looks beautiful.
I have to apologize. Our internet connection out here is very slow at best. And so that's one reason why I decided to mostly stick to a PowerPoint. Okay, ready to go?
Yeah, take it away, sir. Go for it.
Yeah. Thank you all for joining. Like I said, is that I didn't really start off trying to find the theory of everything. I was a young cadet at the Air Force Academy, and I started off trying to figure out why. Figured a way for objects of mass to travel faster than light, but more specifically, why spaceships from other places didn't have to obey some laws of physics that we do. Started looking at the problems associated with superluminal speeds over 30 years ago, and the more I looked at physics behind superluminal speeds, the more I kept coming across the same roadblock over and over again: gravity and gravitational mechanics. So the last 15 years, I began my approach to solutions from a different point of view, and that's when things started falling into place for me. The more I vetted my theories, the more I saw that I did not have to construct any hypothetical or fictional physics to build this theory. Here's kind of the funny part. I expounded on these theories, started to fall squarely within the realm of gravitational mechanics, and started physics models. No hypothetical physics were needed. Simultaneously, many discoveries over the last 10 years have nothing but bolstered these theories. And many of the things that Mr. Salima spoke about will kind of attribute to these as well. I don't have time in this presentation to discuss the whole theory of everything, so this presentation discusses only those aspects of the TOE that pertain to gravity. Afterwards, Tim and others like to hear the next portion of the theory of everything pertaining to the formation of matter will let me know. Without any further ado, we will try on. Before I launch into the theory of everything and how it relates to the formation of gravity, I'd like to provide you with some historical background to my efforts. This slide is a reprint from an earlier paper on the theory of everything. It details one of my primary directives I took while developing this theory. This article goes on to say that Albert Einstein acknowledged the need for such a theory, and only one theory that would combine and describe two very dissimilar but distinct different forces, electromagnetism and gravity, into a single theory. This is his quest that put me on my track. As I built the theory of everything, I need to make sure my theories had a base structure to which to build. So I'll start this presentation on what I consider to be the base structure of the theory of everything. In other words, in any part of my theories, I can't be seen or duplicated in nature through direct observation, reproduction, or proven mathematical or correlated through a cause and effect that was not really already part of the proven physical models that we live with today. I didn't really pursue it. Over the next few slides, I'll start describing the construction of this framework over the reference point, and then I'll tie it into gravity. It'll take a little bit of time, but I'll get there shortly. Years ago, I saw the need to base my theory of everything on either gravitational or quantum field theory in physics. In order to start in the right direction, I need to define how matter and energy interchange. How does matter become energy, and how does energy form matter? Well, we all know well too well how to convert matter to energy, but doing so just the opposite has its kinks. Even today, most scientists will tell you that it's still under construction. I'm sorry if I'm reading, it sounds like I've got a lot of notes with this paper, so that's one reason why I'm reading from the notes, but I'm probably not to read the slides. Most scientists will tell you that it's still under construction and nothing is yet to be accepted as fact, other than at a minimum, matter consists of atoms constructed from protons, electrons, and neutrons. So in order for my next structure to fit in the framework, it had to redefine some more basic but unproven assumptions about what forms matter. And it came to me with little surprise that our most basic theories at the complete odds against each other because of these assumptions. I'm talking about the two theories of which most modern physics are based on: general relativity and quantum field theory. I know Wikipedia is not a really most thorough and detailed of sources, but for this subject, it really does lay out a pretty good story. Right from the beginning of the inception of quantum field theory, I worked on trying to understand its incompatibility with the various frameworks of the standard physics models and general relativity. In order to do this, I needed to solve some of the mysteries of gravity first, and since this is the largest point of contention between the two models, this has been the crux of my work spanning 40 years. And this slide says it quite nicely at the bottom. The reason for incompatibility is neatly worded in the same Wikipedia article. Quantum field theory successfully implemented the standard model that described the three non-gravitational forces: strong, weak, and electromagnetic forces. The base structure that should be an absolute rigidity, nothing abstract, unproven or theoretical formation. So let's start with the first structure. The first structure of my framework is that matter and energy can neither be created nor destroyed. They can and they do interchange with each other every second, the last 14 plus billion years. But that's all that's out there is out there. Before I go any further, is anyone in this audience that think that this fundamental law of physics is not a good place to start? And I don't think I have anybody's screen up, but that's a separate screen. I'll continue. Of the four accepted fundamental forces of the universe: strong nuclear, weak nuclear, electromagnetic, gravity, only electromagnetic forces are not subject to speculation or competing theories. Nobody's proven what causes gravity. We have some good ideas, but only that it's a property of mass. And all the fundamental forces, the theories describing gravity, have varied the greatest. Of all the speculation on gravity made it the easiest to set aside, so I excluded it. Of all the theories, of all the structures in my construct, this is the most controversial. Because to accept this construct, you must be willing to question the validity of what we've come to describe as the fundamental forces of the universe. So before I went any further in my universal framework of physics describing the cause of other fundamental forces, I first needed to figure out what causes gravity. But as I said in here, gravity and how it relates to the universe, gravity is not a fundamental force. And I'll go on to explain that, how we cause that later on. Let's talk about the universe on a general relativity macro scale. We'll get to gravity, bear with me. Up to about 89, most people assume there are only three states of matter of existence: universe, matter, energy, and the void of space. However, lately we have postulated there may be even more than three states, according to several websites, talking about the density of matter, the density of dark matter, and the density of dark energy. But I had to ask the question, what if the universe only had two states of existence, matter and energy? So let's go back to the first positivistic theory. Matter and energy can neither be created nor destroyed. What if the void was nothing more than an energy field? That satisfies the notion that 72.6% of the universe is dark energy. If you substitute 23% dark matter for 23% EM, we have a balanced equation at this point in time. The third structure of this framework comes from the difference of old school physics definitions and modern physics definition of space. When I was in school, I was taught and believed that space, I'll refer to as a void, is comprised of matter, energy, and nothingness, the void of space, and that the energy is comprised of a fixed percentage of atomic matter, about 4.5%, and electromagnetic energy, about 23%, and nothing else. Many of us were taught years ago there's only the void of nothingness in space. But I postulated the void of space is its own energy field. And while this energy field serves the same purpose as the ether, it's not quite the same, and more similar to what we might think of as dark energy. Now we can tie this concept into the force we call gravity and what causes it. I put a reference to a really good book at the bottom of this slide, and if your field of study is gravity, I highly recommend it. I've written the book, and I spoke to Dr. Tyson on the phone several times, and we're both kind of barking up the same tree. And the bottom line is he doesn't think gravity is a force either, but then again, like I said, that's a discussion. Why can't gravity be a fundamental force? Well, here's some of the reasons. The mainstream scientific community has long since contended that gravity is an attractive force created by matter, a property of mass. We know that gravity behaves like electromagnetism, except that mass does not have an opposite force to attract it. This was Einstein's dilemma. And if all efforts to define it have been biased towards that effort, we've even created negative mass to answer this dilemma. I look the other way. Besides protons and electrons, what if there's another single charged particle in the universe? After all, we have hypothesized and seen evidence of magnetic monopoles. Now let's circle back to the physics of gravity. You'll notice in one of my slides, in this particular slide, I've gone on to talk about gravity and magnetic mass, but the bottom section says magnets do lose mass as magnetic fields used to create work force as well as unstable matter. But if I add mass to an object, making it more dense, how can it create its energy signature of gravitational force? And that kind of says like double dipping at the energy, because now we're creating matter and energy. The next significant strength of my framework was that the force of gravity was based in particle physics. Not a big deal, you might say. After all, over the last 30 years, science has generally tended towards a postulate that most of our physics universe is particle based in both gravitational and quantum field theories. Almost every paper or article I've ever read about governing the fundamental force universe all speculate that gravity is particle based, often referred to as a graviton. As a humorist, I remember reading a classic science fiction story written in 1941 that referenced gravitons. By defining the force of gravity as particle-based, I was able to use known, proven particle dynamics and definitions from the standard physics model to validate my hypothesis. As I built this construct, I theorized that if the force of gravity was particle-based, and according to gravitational general relativity physics, this particle would have to physically behave as every other particle we've proven in existence. Light particles, photons, electrons, protons, radiation, the whole gamut. Gravitational particle has to behave like every other known particle. Over the years, I've come to define some of the physical characteristics of gravitational particle or gravity particle, and then made it fit to contemporary physics and current observations concerning mass in the universe. So now let's start tying gravity to the physics of void energy. My next construct of this unifying framework of physics was this. The void energy is comprised of these particles, and it is its own unique particle. Is this particle a graviton? Yes, in the sense that it is responsible for the force of gravity, but no, not as it's defined in current theories being discussed in general relativity and quantum field theories. In my model constructs, it's usually referred to as gravitons, but I recently put me in a pickle with the US Patent Office. So in this form, I often label it as I don't label it as a graviton, I'll call it a GravX to avoid confusion. And that's the subject for a different story. Now let's discuss gravity and gravitational particles. As you can see from the slide, I won't repeat it, but this kind of defines some of the portions of how the gravitational particle is defined. One of my first definitions of the gravitational GravX particle is it has an opaqueness to matter or mass based on the density of the matter. It has energy, it's a charged particle. And later on, I went to define this energy as electromagnetic in principle. GravX has a negative charge. GravX behaves in a predictable manner like every other charge energy particle when reacting to itself. GravX also behaves in a predictable manner like every other charge energy particle when reacting to matter. I wanted to prove the validity of these definitions by just running some simple experiments. The GravX particle behaves like every other charge energy particle. Then all I have to do is mimic its reaction to matter using similar known energy particles interacts with matter by observable means. I chose the photon because while all matter is not opaque to the photon, glass, clear liquids, etc., matter can exist in a translucent to opaque state of light, metal, plastics, organics. As I described the experiment, you'll come to the realization that you can run the same type of experiment using electrons or even energy particles like gamma rays. I chose to conduct an experiment to define the opacity of GravX within the same parameters of photons reacting to mass. As I said earlier, the experiment can be repeated using kind of electromagnetic particles. The slide you show is an excerpt from one of my papers on gravity. I basically conducted an experiment where I put in a very sensitive photocell between two opaque balls. I did this experiment in a special room used for photography studio. It was universally lit from all sides, including the floor, walls, and ceiling. It was repeated using orbs that were completely opaque to light, as shown above, and using orbs at varying degrees of opacity. The results were always the same. The decrease in the amount of light that penetrated the orbs were based on R squared. This meant that there was more abundant light per volumetric unit of measure around the periphery of the orbs than there was between them. It's interesting because I've got some notes here. Tyler, I'll reach out to you. I saw you just showed up. You talked about magnetic monopoles, and that caught my attention because in your particular thing, you talked about your monopoles have an inverse of R squared. And so that kind of fits my theories as well. But let's take these findings and tie them to GravX and the particles in gravity. Void energy composed of GravX particles is evenly distributed throughout the universe because they're in a constant state of repulsion to each other. They're negatively charged particles. As such, the pressure gradient of the universe wants to remain constant, being constrained by distance. An object of mass is a localized low pressure point in void energy because by volume, the positive charge of the nucleus of the atom is significantly greater than the negative charge it displaces. So localized void energy is increased around the object of mass to compensate for this difference. And like light passing through the black orbs of my experiment, it cannot pass through mass unrestricted. As I said, mass is opaque to it based on the density. In order to maintain a constant regional pressure of void energy, I'll use my little mouse here to explain that. Pressure exerted to the object is higher. As the object of a mass approaches each other, a shadow zone forms between them. And you can see this down in here. And what you're looking at are, let's say, a planet, a galaxy, a star, and the whole upper screen here showing you a section of the universe shows these individual objects of mass, but like the whole slide, the average is between the same, but because these individual objects of mass are so much by volume more dense in protons than the negative charge, that's why they have a greater field against them. As the objects of mass approach each other, a shadow zone of lower void energy develops between them. In other words, the pressure gradient surrounding the volume of void energy in mass remains constant, but the pressure gradient begins to lower between them. In order to keep regional pressure net zero, the higher pressure gradient of the void energy surrounding the objects actually begin to push the objects together. I know this sounds strange, but bear with me. The more dense the objects, the less opacity to gravity X particles, hence the greater the inward pressure. I know I've taken a roundabout way to get here, but this theory fits all gravitational general relativity physics models on how to create a perceived attraction force of gravity. And in other words, objects of mass are not pulled together through the creation of a gravitational force, nor are they drawn under the hypothetical bending of time and space. As objects of mass get near each other, they are pushed together with an ever-increasing intensity in order to keep the regional forces of void energy equalized. The force of gravity is measured as a lack of void energy pressure between objects of mass. In summary, I've kind of narrow the scope and definition of void energy and graviX particles that pertains to the creation of the force we call gravity. Now I'll define several key aspects of the gravitational particles, graviX particles, how it relates to the force we call gravity. Void energies comprise entirely of void X gravitational particles. GravX particles occupy all space not occupied by mass or matter or other particles residing in the electromagnetic spectrum. Void energy has density and pressure. Therefore, void energy has pressure gradients. GravX particles are negatively charged. Their opacity to mass is based on atomic density. The greater the mass, atomic density, the greater the opacity. This means that as matter goes through the void energy field, the void energy coefficient of drag is proportional to mass density. GravX behaves in accordance with the compressible particulate gas laws. Pressure and density as it varies in strength from near zero to strong nuclear. GravX are smaller than electron, but too large to exist within the nucleus of the atom. GravX may or may not have mass, but I theorize if it does, it's much smaller than even any known particle discovered to date, but it's 100 transparent to light. These are the major definition of GravX particles, and some of these issues play into other areas of the theory of everything, but I know as far as gravity is concerned, these fit the pattern. Kind of in summary, as far as gravity is concerned, the void is an energy field, therefore it must have pressure and density. The interaction of void energy particles mimic the behavior and known properties of any or all of the other known energy particles, especially when interacting with matter. The simple mechanical model says that as two objects of mass or matter approach each other, the density of the mass determines the density of GravX particles between them. As the density of the space between these As the distance between these objects of mass decrease, so does the density of the localized void energy field between them by a ratio of r squared. As the density of void energy between objects of mass decreases in a stable field of void energy, so does the localized pressure of void energy surrounding the object of mass, and therefore the object of mass are pushed together from an exterior pressure. In other words, gravity sucks, right? Let's tie this together as far as gravity and anti-gravity are concerned. And this work plays a large part in anti-gravity. In simple terms, the force of gravity is a resultant force measured between the opposing surfaces of two objects of mass, and that this measured force is the result of the pressure differential between the exterior surfaces and the inward-facing surface of these two objects of mass in close proximity. Anti-gravity is the artificial means of redistributing the pressure gradient of void energy around the object of mass. And here's a particular note. Anti-gravity can be mechanically or electrically induced. Well, this kind of ends a formal portion of this presentation. But before I go on, I wonder if there's any pressing questions out there. And I don't know if I can get to that view or not, sharing my screen. I think I can. Okay, Tim, if you want to mute, anybody has any pressing questions so far?
Well, you know, typically we do questions at the end, Mike.
I'll hold off on that for a second.
Okay, okay.
Yeah, I continue on here. Like I says, I talked about this portion of the theory of everything in gravity and anti-gravity. And so, however, but during a large portion of my slides, I kind of kept asking myself, if gravity is not a fundamental force of the universe, and when I was doing my studies, how is it possible to explain its properties using other known forces and demonstrate how gravitational properties can be accounted for using other conventional physics phenomena? And so for the remainder of this presentation, I'll walk you through some of my observations and findings, after which we'll launch another QA session. So I think that should satisfy you. Okay, on to the next portion of the presentation. That one didn't last very long, and this one shouldn't last very long either. The following slides are used in conjunction with this theory in anti-gravity. And as I said, these are observations, studies, and findings that support many aspects of this theory. And they're a whole lot more interesting than the last portion, that's for sure. Okay, let's just jump right in. Since this discussion of the theory of everything is based towards gravity and anti-gravity, I'll jump right into the most controversial part of the theory. If gravity is not a fundamental force of the universe, just what is a black hole? Over the years, one piece of evidence that we've gathered proving the existence of black holes is that we've all seen electromagnetic radiation come from the axis of them. Stephen Hawking had a theory about this, but it kind of entailed quantum field theory. However, quantum field theory is nothing more about general relativity gravitational mechanics on a macro scale. In accordance with gravitational field theory, that's not much to do with gravity. So the question I wanted to ask this is, and you have to talk to us, is if light can't escape a black hole, then how in the wide world of sports does a charged particle of mass get out of it? Another piece of evidence supporting the theory, I'll pull my notes down. Another piece of evidence supporting this theory is a time-lapse photography of stellar objects approaching a black hole, accelerating around it and getting them spit back into space. And I'll click on a little video here if I can pull it up. I don't know if how many of you seen these videos, but there's a couple of them out there. My son introduced to me this, one of them from physics class. Where did you go? Here it comes. There's no sound to this video. I'm sorry, I'm still waiting. Okay, what you're looking at, there's a black hole in the center of the screen. And there's several stars or some very large object going around this thing. I'll start it over again. This is one of several videos. This is a time-lapse photography of actually over 20 years. And it's been estimated that the closest approach to star was going about 18% the speed of light as this thing got around it. The one major issue I've had with this observation in any orbiting mass going around or getting slung around a black hole is just this. According to gravitational mechanics, all those stars should have been torn to shreds due to the gravitational variations and centrifugal accelerations they approach, yet none of them do. In any of the videos we've seen, none of these videos, none of these stars get torn to shreds. The supposition that there's a black hole of immense gravitational pull at the center of most gravities, and this formation would occur naturally, though, if there was no gravitational pull emitting from the center, but instead if there was an area of immense low pressure at the center. This also means that matter could escape a black hole if it was just that, a negative pressure area in the void energy. However, when approaching a black hole, unless the approach of the matter is perfectly normal to the axis, any matter approaching the black hole would either get slung away or establish an orbit around the hole. One of my key objections to current theories concerning black holes and other overly dense stars is the disproportional amount of massive objects in the universe. Most of the stars in the night sky are about the same density of our sun, 1.4 times 10 to the 3 kilograms per meter cubed. The large gas giants tend to have lower densities. The large gas giants have lower densities than planets like Earth, which are 5.2 times 10 to the 3, or Jupiter's density is about half of the Earth's, the same. White dwarfs have a density of 10.9 kilograms per meter squared. Neutron dense stars have a density of 10 to the 17th kilograms per meter squared. So I'm just kind of wondering why there's not much in between. There's the black hole at 2 times 10 to the 19 kilograms per meter squared, white dwarfs at 10 to the 9, and neutrons at 10 to the 17. It's estimated there are 10 billion white dwarf stars in the Milky Way, but that's still only 0.01% of the Milky Way stars in the Milky Way. And there's 3,200 neutron stars in the Milky Way, but that's less than 0.000032%. And we have one black hole. If black holes are constructed by matter, then why, after 14.5 billion years, are there not more out there? But enough of black holes, and we'll get on more on that. And I'm sure you guys have the right questions down as we get along. Anytime light travels through a clear medium of different densities, it will bend as it passes through. Lensing has nothing to do with the density of forces. It's all about the density of changes of density of matter. A superior mirage is one in which the mirage appears to be located above the real object, but is actually far behind it. A superior mirage occurs when the air below the line of sight is colder, more dense than the air above it. And a mirage is not a source of light either. It's a reflection of light. So if the density of gravitational particles are the greatest in and around an object of mass, then they would appear to cause a superior image, superior mirage. That's the effect we call gravitational lensing. And light is highly subject to that. This kind of gets into the bulk of many of the discussions. The slide is an excerpt from a publication in Physical Essays by Dr. H. Aspin, Theory of Antigravity, published in 1991, then appended in 1997. This paper, as well as this phenomenon, kind of started me on the path towards using the theory of gravity, theory of everything, to describe gravity. Because this slide is a repeat of text from another paper, I don't want to abridge any of it, and it's a lot to digest, but let me kind of read through it and get the highlights here. Dr. Aspin talks about the fundamental question of the anti-gravity realm. And he says at the very onset of this discussion, it's necessary to distinguish between two schools of thought as to the action involved in anti-gravity. Most of those researching this field believe that mass retains its full and normal gravitational property, but that the anomalous levitation or propulsion effects comes from an out of balance force somehow is developed by exploiting the absence of centrifugal effects when a spinning flywheel offset from a separate axis rotation. This is called precess. Now, this is kind of important because he says others, including this author, this is Dr. Aspin talking, subscribe to the view that there is a loss of weight of the force precessed mass in the flywheel, and that this is the underlying energy action of the vacuum field plays in the role of this enigmatic behavior. And this has a lot to do with some of the papers I've heard about here about the loss of weight. The distinction is most important because in the first case, the action is a dynamic action akin to the effect of an electric or magnetic field that can act across empty space to produce force developing thrust. Like I said, he doesn't relate to this. He subscribes to the view that there's a loss of weight. I can supply a copy of this paper you like, but I'm sure many of you might have seen it. But before I go into this case, let me go to the next slide. Later on in the same paper in 1997, he appended it because there was a number of questions concerning the experimental evidence he'd put to date. Once again, under Chapter 7, Experimental Facts. To the author, the most significant facts of this experiment is presented to anyone who's witnessed the Lafayette lift, and that's kind of a picture you saw earlier of it, that lifting a heavy spinning flywheel by applying a slight manipulating force to a supporting shaft. The end of the shaft remote from the flywheel is supported by the crook of his little finger on the outstretched shaft. The lift force needed to be less than 1 kilogram, whereas the wheel weighed 8 kilograms and the supporting shaft weighed 2.7. Readers of difficulty believing this should examine the photograph of demonstrations in reference for page 64. Once again, he's referring to the Lafayette experiment. At this experiment, there's no vibration and the evidence points to the wheel being able to lift more than its own weight. Note that he refers to the evidence of the wheel being able to lift more than its own weight. I've done this experiment several times and I lost about half the weight of the shaft as well as the entire weight of the spinning disc. Anybody that rides a bicycle and repairs your own flat tires would probably play this experiment. Grab by the axle, spin the wheel, it holds around, but it also starts turning, and that's important. Of course, none of these explanations satisfy the force vector diagrams required to describe any free body in motion or being static. If force equals mass times acceleration, and the wheel is not accelerating towards Earth, and it's not accelerating its orbital path, then where did the force of gravity go? I'll go back one slide and explain it to you where it went. He said it's right there, at the very last bottom. He said the distinction is most important because in the first case, where he doesn't believe the mass has changed, the action is a dynamic action akin to the effect of an electromagnetic field. that can act across empty space. Now, his fallacy was that it's not empty space. I didn't get a chance much to discuss my introduction, but I did major in aeronautical mechanical engineering. And so my primary love in life has always been physics. And I remember seeing a lot of these physics experiments in my aeronautical engineering background. So these are some of the reasons why I ended up in particle dynamics along this thing. These are some of the, this is an excerpt from my own publications on anti-gravity. The slide discusses the theorems surrounding particulate flow around rotating objects of mass. It states that when a rotating cylinder is traveling through a flow of compressible gas, the pressure differential on the laminar flow of gas creates a force vector that will act against the rotating cylinder. So concerning the anti-gravity wheels, and these are still some more experts from my previous publication on anti-gravity. The laminar flow about a rotating cylinder gravitons or gravex particles suspended in void energy will exhibit flow patterns similar to the Magnus effect. In the laminar flow, an increase of graviton density results in an increase in surrounding void energy pressure. The increase in void energy pressure will cause the gravitons to attempt to equalize in volumetric density through and about the cylinder. This will cause the force against the rotating cylinder just opposite direction found in the Magnus effect, and result of a force is pictured above. The Magnus effect that you've seen works on golf balls and short cylinders and discs as well. If you recall earlier, I mentioned a mechanical means of producing anti-gravity. This is how it, and I'll show you how this correlates to standard general relativity physics gravitation particles. But in a nutshell, when you look at a flow of an object, a rotating disk, a rotating cylinder, through a flow of compressible particles, then you have the Magnus effect takes effect, and this thing actually, and then, like I said, actually produces a force opposite in the direction of compression. In the picture above, you're looking at a free body diagram of the anti-gravity wheel, the rotating disk, from the side on the left and from the earth below the disk and from above it on the right. The forces and direction due to gravity, due to the mass of the disk and the mass of the shaft are shown in red. The beige curved arrows denote motion. The reader will note that the Magnus diagram in the center there, the force vector pictured in yellow is identical to the force described in the gyroscopic precession in an anti-gravity wheel. And it's the same magnitude as the force of gravity on the disk. As long as the disk continues to rotate and there continues to be a positive velocity flow in the field of gravitational particles around the disk, the velocity vector is the green arrow in the Magnus diagram. It will experience the force normal to its circular path about the fulcrum. Stop the disk from orbiting the fulcrum, and the lift forces suspending the disk cease to exist. In other words, if you were to pick up one of these anti-gravity wheels, start this disk up, from one end of the shaft, you can pick it up, and the shaft weight and the disk weighs absolutely nothing. It supports the weight of the shaft as well as the weight of the disk. But either the thing has just lost its mass, or it's actually negating gravity, because the yellow forces, nothing accelerates. Let's add up the sum of the forces, which much equals zero because nothing's accelerating. In the case of the anti-gravity wheel, the void energy force against the rotating cylinder can only react between negative pressure created by the combined mass of the rotating disk and shaft and the earth, and it is proportional to the combined mass density, no more, no less. In the case involving the anti-gravity disk, the spinning disk does not create a reactive force in the upward side of the rotating object of mass. It only equalizes, negates the pressure gradient between the disk and the earth. No matter how fast you rotate it, it doesn't change. All it can do is neglecting the gravitational particles, causing the collapse between the two objects of mass. In other words, there's no force acting on it. It's just negating the forces pushing them together. As you might imagine, I've played a lot of experimental things. That was one of my previous jobs. And I've already devised an experiment along the Cavendish and cruiser torsion balance experiments to prove my theories governing these anti-gravity wheels. I haven't got a chance to put these together yet. And as you can imagine, this is quite an endeavor, but over the next few years, I hope maybe to build one of these things. By now, you might have come to the conclusion that the void energy field is a lot like ether, referenced by many astrophysicists and astronomers alike, including Albert Einstein. And I would tend to agree, but it isn't quite. Think along those lines, what would happen to an object of mass having been given an initial accelerating force as it traverses through a resisting energy field? According to gravitational mechanics, general relativity mechanics, gravitational mechanics, as soon as the force accelerating the object is removed, it would slow down. The slide is a quick compilation of sightings of objects moving through space. Note the asterisk in the last bullet point. The same sign, in this last bullet point, why is there nothing of mass? I put in that the same ScienceAlert.com article that I made reference to. It made reference to a star SGRA, which I think is Sagittarius A, in an orbit in the Milky Way galaxy with an orbital speed of 24,000 kilograms per second, or kilometers per second, or 8% of the speed of light. And once again, here's that dilemma I have when trying to describe forces of these orbitational speeds based on general relativity and gravitational pull. Why doesn't it get pulled apart if it's orbiting something at 8% the speed of light? I've made several predictions over the years concerning this theory, several which have come to fruition. This is another prediction based on my theories. Because objects of mass are not transparent to gravitational particles in the void energy field, any object of mass that is initially accelerated from a large force, even a massive cataclysmic event such as a supernova, and even if the initial velocity is significant percentage the speed of light, it will slow down exponentially based on its mass. And as nothing of mass will ever achieve a steady state speed across the void through the void energy field of more than a fraction of the percent of the speed of light. That doesn't mean, however, that you can't go faster than the speed of light. Let me say that again. I don't think you're ever going to see anything traveling across the void energy field of the universe, traveling more than a fraction of the speed of light. Even its initial acceleration is incredibly quick. It will slow down very quickly because based on its mass, it won't be able to pass through the void energy field of the gravitational particles. I might be wrong, but that's what I'm thinking. And I've seen a lot of topics and discussion about gravity waves. And so I threw a slide up on there, and being a mechanical engineer and being an aeronautical engineer, I kind of decided to talk about gravity waves. A wave is a disturbance that moves energy from one place to another. Only energy, not matter, is transferred as a wave moves. The substance that a wave moves through is called the medium. That medium moves back and forth repeatedly, returning to their position. But the wave travels along the medium, it does not stay in one place. This means that if gravity existed as a force and it somehow created a wave, it would not be an outwards wave like weak nuclear, but it'd be an inward force wave like strong nuclear. There could be no gravitational force waves unless the force of gravity was caused by a repulsive force, such as void energy suggests. I predicted we would discover gravity waves several years before they actually did in September 2015 in one of my papers. Accordingly, what we think of as gravity waves would be completely possible and explainable in this theory. In other words, if several objects of mass collided and their force was of their gravitational particles was pushed out, that ripple would continue across the universe as they bump into more particles. And so it fits the model very nicely. Newton's first law of motion states that a body at rest will remain at rest unless it's acted upon by a force. And a body in motion will remain in motion unless it's acted upon by a force. So what you're looking at are two pictures. The first one is a piling in a flow of water, And if you could picture that piling, maybe those two girders, let's say they're attached to a boat. So as the boat's moving along, it's pushing this force of water with it. And so it's got resistance to it. If the boat stops, the current across the front of the boat will slow it down a little bit, but eventually this thing will continue moving in space. The second picture on the right is an opaque object of orb in a compressible gas flow. And it looks very similar to the other one on the left, non-compressible. And what this basically states is that if you take an object of mass that is opaque to void energy, to gravitational particles, and you attempt to move it through a field of gravitational particles, it will resist initially. But as it picks up speed, or as you continue to push it, eventually it will move the particles around it with it to a certain extent. And that's why a steady state object will continue at a very slow steady state, but a very slow steady state. And so this kind of fits the theory of a particle not being able to go through an object of mass or based on its density. But I think to my point myself, this is the only theory that I've ever come across that actually supplies the physics behind these two laws. Now, this was going to be the conclusion of this portion of the presentation. However, a recent discussion in the last forum caught my eye. And Tyler reached out to you. Tyler Sokol gave an excellent presentation equating the theoretical existence of magnetic monopoles to UFO spacecraft propulsion. What caught my attention was equating the strength of these theoretical particles to R squared. This does fit the theory of everything as it stipulates. The electrical strength of void energy is based on R squared. And the gravitational particle in void energy is a negatively charged particle. To create that anti-gravity, to create negative gravity, you can also use both mechanical and electrical means to do so. And we've talked about this in many of the references I've seen about creating anti-gravity through mechanical or electrical means, particularly electrical means. And so this is a kind of akin to some of the Hutchins effects or even the graviflyer. And this also means that the impulse gravity generator is probably using electricity to manipulate the void energy. So in other words, I basically sat back and said, if I've created an energy field of the ether, and if it's tiny charged negative particles, then I can adjust their behavior. And creating anti-gravity would literally just be moving these particles around and creating either negative or positive forces of gravity between objects of mass, or forces of electricity between objects of mass. Okay, I think this kind of concludes my presentation.
Let me put this thing on speaker view. We got 46 people in the room. I want to hear a big applause for Mr. Mike Rys.
Well, as I said earlier, Tim, this portion is just anti-gravity. And if you would like, you can, I'll bring several other pages, like a book of, but I can bring several others, particularly concerning matter and the formation of matter. And that's like the next 2-hour slide presentation. So maybe
Okay. Yeah, absolutely.